Hello everyone, this is Niteen Mohod, and here we are going to study the photodiode, which is one of the optoelectronic devices. Photodiode is also known as photodetector as it can detect the light. Also, it is identified with the name light detector or photosensor. Is basically a semiconductor PN junction which is first operated in reverse bias and then illuminating it. On applying small reverse bias voltage, very small reverse saturation current initially flows through the photodiode, which is represented as Is or I lambda, which flows because of the thermally generated electron hole pairs. As this current is very small and at this time no light is incident on the photodiode, therefore the current which flows in this case is referred as dark current, and which is very small in the range of nanoamperes. In short, photodiode consumes light energy to produce the electric current. Here you can see the diagrams which shows the arrangement in photodiode, circuit diagram and the symbols. To focus maximum light on the reverse bias junction here, the lens is fixed in the cap of the unit. Active diameter of this device is about 2.5 mm but is mounted in standard TO5 package with window on the top to allow maximum incident light to focus on this reverse bias junction. Through the glass lens, light is focused on the reverse bias junction. As you can see, the light is coming like this, and through the lens it is focusing on the reverse bias junction. Depletion region here is wide enough as the junction is reverse. As the light particles, which we call as photons, falls on the junctions, it imparts energy to the ions and generate more electron hole pairs. Number of electron hole pairs generated is proportional to the intensity of incident light, and increase in electron hole pairs leads to increase in reverse current, which is called as a photocurrent. So far the characteristics are concerned, you can see the characteristics are plotted between reverse voltage and the current, that is reverse current, and they appear in the third quadrant of the graph. As the reverse voltage is applied and the reverse current is obtained, characteristics for the photodiode are obtained in third quadrant. Dark current of the photodiode is very small as shown in the graph, and this you get when no light is incident on the reverse bias junction. When light falls on the photodiode, the reverse current increases and is directly proportional to the intensity of the incident light and independent of the reverse voltage. Intensity of light is measured in lumens per square meter, and as you can see the graph is plotted between VR, that is reverse voltage, and IR, that is reverse current. You can call it as also I lambda for various light intensities, and this shows the characteristics of the photodiode. Some of the applications of the photodiode are as follows. They are very fast, hence used as a photodetector for both visible and invisible light. They are used in alarm systems. For counting of objects on conveyor belts also it is used. It can be used as a sail also. Then as a variable resistance device, in light intensity meters it is used. In high speed logic circuits, in fiber optic receivers, in demodulation, then in switching, then in character recognition, then also it can be used as an encoders and in optical communication equipments. I hope the idea about the photodiode, its working, characteristics, construction, and more important, the applications are clear to you. Thank you.